Good day, everyone. I am Professor Jong-Yih Kuo from the Department of Computer Science and Information Engineering at National Taipei University of Technology. My research interests include software engineering, intelligent systems, object-oriented design, and cloud computing. Since the second semester of the 2020 academic year, I have been integrating open textbooks, OTB, into my teaching. To date, I have applied OTBs in 6 courses across 7 offerings, including cloud computing, computer programming, network programming, computer organization, and artificial intelligence. Open textbooks are freely available for use, reproduction, and modification. This flexibility eliminates concerns over intellectual property rights and allows educators to innovate more freely. My teaching strategy focuses on transforming OTB content into video materials and combining them with innovative teaching models to improve students' learning effectiveness. To begin, I select OTB materials aligned with the course learning objectives. An OTB can serve as supplementary reading for selected chapters. For example, Introduction to MIPS Assembly Language Programming offers detailed explanations of MIPS implementation, making it an ideal supplement for Chapter 2 of Computer Organization. It can also serve as supplementary foundational material for advanced courses, such as Artificial Intelligence, where theoretical concepts like gradient descent are further reinforced. The process begins with the teacher producing videos for the earlier course chapters, which students are encouraged to study before class. Later, students are organized into teams to collaboratively create their own instructional videos, following the format and style demonstrated in the teacher's examples. Through this process, students engage in team-based collaboration, develop presentation skills, and deepen their understanding of the subject matter. Furthermore, I incorporate innovative pedagogical methods, including flipped classroom, game-based learning, and team-based learning, to diversify the learning experience and strengthen engagement. For example, in my computer organization course, I adopted an OTB-based collaborative approach, where teachers and students jointly constructed an OTB video classroom integrated with the flipped classroom model. The OTB used was Introduction to MIPS Assembly Language Programming from the LibreTexts platform. I extracted the key knowledge, created 5 instructional videos using screen recording software, and uploaded them to YouTube. In the pre-class learning phase, these videos served as preparatory materials. The video links and related questions were shared through the real-time feedback platform Zoovio. Students were divided into groups, discussed the pre-designed questions, and submitted their responses collaboratively via Zoovio. During class sessions, I reviewed the students' Zoovio responses with the entire class. Both incorrect and outstanding answers were displayed and discussed together. For incorrect responses, I pointed out and corrected the misconceptions. For excellent answers, I highlighted them as exemplars for peer learning. This process enabled students to reflect on their performance, understand their learning outcomes, and achieve shared growth through guided feedback and collaboration. After class, using the same team structure, students were assigned additional chapters from the OTB. They first reviewed the teacher's videos, then created their own presentations and 15-minute teaching videos. This activity encouraged teamwork, creativity, and a deeper grasp of the material. Following the student video presentations, classmates participated by liking and commenting on YouTube, creating a friendly and motivating learning environment. At the end of the course, a survey was administered to evaluate learning satisfaction. The results showed an overall satisfaction rate of 84%, with many students expressing that the video-based learning module allowed them to study repeatedly at their own pace, review unclear content, and keep up with the course effectively. My courses maintain rigorous academic standards, with an average passing rate of 70% and an average score of around 70. Notably, over 10% of students score above 90, demonstrating that dedication and effort yield excellent results. This OTB-based instructional strategy has consistently produced learning satisfaction levels above 80%, while also establishing an effective mechanism for teacher-student co-created educational videos. Students provided many positive comments, such as, "The teacher is very dedicated, and the recorded videos are detailed and clear. I can rewatch the parts I don't understand for better comprehension. The lecture materials are rich and informative. I learned a lot, even though the process was challenging to date. My students and I have jointly produced 278 open educational videos. These videos not only serve as valuable classroom resources but are also shared publicly on YouTube for anyone to access freely. Our ongoing teaching models for applying OTB include game-based learning, inquiry-based teaching, and teaching practice research projects. It is my hope to continue this hybrid, adaptive, and open approach, one that draws from open resources and contributes back to the open community, becoming an active part of the global open educational resources (OER) movement. Thank you for your attention. The more open the resources, the more effective the teaching.